Awesome. Thanks, Tony. And welcome to our last EurekaFest 2021 event for our Invent teams. Hello, my name's Lee Estabrooks, and I think many of you know me. And for those of you who are visiting, I'm the Lemelson-MIT Invention Education Officer. It's really my pleasure to be here today and to congratulate our Invent teams. And right now, I'm going to say a kind welcome to Nate Ball. Nate, it's great to see you again. It's been a while, but Nate's been a longtime friend of the Lemelson-MIT program, and he's going to be one of our special guest speakers today to help Tony and me send the Invent Team students off to their next invention. So Nate, welcome, and we're going to let you share your slides. I'm sure you've got some great and exciting things to share with all of us.
Thank you. It's seeing the event teams participate again. It's been long. I had to be off site today, so I'm not near the most stable internet connection. I'm on a hotspot from my phone and sitting in a car, which is safely parked, by the way. I've had a couple fun slides to share. Some coolest, latest stuff from my company, Atlas Devices. I thought I would tell a bit of our story and a bit of my own personal story and what led me into engineering and connecting a lot of the dots of inventing and how I've been able to turn that into a pretty exciting career. And then I'll try to keep this to about 30 minutes so we can have some time for Q&A afterward, because that's honestly the most fun part. So yeah, thanks for having me, and it's great to be with you all. Yeah, awesome. It's the Q&A that will really help. And I'll see if I can answer real time. I will, but we'll do some stuff at the end. But definitely chat right in there. So a little bit about myself to begin with. I grew up building stuff and didn't really get to watch a lot of TV. But my parents were amazingly lenient about the kinds of tools they let me use and the kinds of projects that they were cool with me engaging in. So here's a picture of me as a kid. Building my first go-kart. Didn't really have access to motors or engines, so I had to use gravity down our steep driveway, which resulted in a lot of crashes during the testing process for important features like brakes and steering, as I figured out how to try to replicate Lego steering mechanisms out of the 2x4s I could actually build with. I'm sure, like a lot of you, I've drawn a lot of inspiration from Legos over the years. So I started playing around with things like this at a really early age, and it was interesting to note how, in retrospect, after I got to MIT and got to do real engineering school, I realized the lengths I had to stretch myself to make some of these things work caused me to have to be really creative. I had a lot of constrained resources. I didn't have a big machine shop at home. I was working with a lot of wood. And I'm gonna shrink myself down really quick so you guys can see the picture a little bit better. Here we go. So a couple more projects I built. Again, without access to motors, I was trying to make a land sailor instead of a go-kart motor type thing. So my parents would take me to the beach, and I had to figure out how to make the land sailor fold up because it wouldn't fit in the car. So I just, like any exciting project, you have a vision for what you want to create, and then you try to pull it off. And you run into all these surprise challenges along the way that you didn't even anticipate, but that cause you to have to think creatively and get past the limitations of whatever the guardrails are in your project that are limiting the way that you thought you were going to be able to build it. So I drew inspiration from just whatever seemed cool to me to build, whether it was forts like you might see in the Calvin and Hobbes comics, to a potato gun that's powered by air pressure, because I didn't want to mess with any hairspray and flames. But that's my granddad and my great uncle shooting the potato gun off toward the ocean at the beach, and a little kayak. And then even the most complicated thing I built when I was before college was this Tesla coil project that really stretched my capability and my learning. I think I worked on that thing so I found out about Tesla coils, these amazing lightning making machines invented by Nikola Tesla like 120 years ago. I wanted to build one so bad. I was an 8th grader And I knew very little about electronics and even less about the physics involved in making one work. And I worked on that thing for 3 years before I even got the smallest sparks coming off of the terminal. And sometimes that's what it takes if you've got this vision and you've got so much to learn before you can make it really happen. But because I was so excited about that idea, I just wanted to see those stars and that lightning get made with this machine that I myself so much that it kept me going and it kept me learning. And I get dozens and dozens of tries before that thing was finally functional. So I feel really lucky because I have gotten to engineering. It turned out I got to school and I got to MIT. I found out more about what engineering really was and that I could get paid to build cool stuff. That was pretty much the dream for me. And I figured I really want to do this and figure out a way to make things that I envision real, but as a profession. And I'm pleased to share to do that, but in ways that I didn't really expect. Oops, I'm on the wrong side here. There we go. I'm using some new tools today, and it's to myself around and make a tiny face for me. This is me hanging below a helicopter, an invention that I built with my friends up into that helicopter as it hovers 100 feet above the ground. This is one of many moments I've had in my engineering career so far where I am just having to pinch myself to see if I'm dreaming because I can't believe how ridiculous this is. Let me just note the caveat that it's not always like this, but it can be at its best. And it is the biggest thrill. What got us into that situation was we developed this cool new technology, a powered ascender, which it's just like the things out of Batman and James Bond. You have a rope overhead, which maybe you even put in place with a real live grappling hook launcher, which we also have. You get that rope overhead, you take this little device, clip it to your harness, wrap the rope through it, pull the trigger, and up you go. You can do that with a rescue load. You can do it with a second person. And it's actually used all over the place, from rescue with helicopters like we're seeing here, to climbing buildings, to even having utility line crews use it to get up and access live conductors. Never would I have imagined all the adventures we'd get ourselves into just as a result of this one invention. And I think that's one of the most exciting things about inventing stuff and bringing new technology into the world from what's in your head, is that you start off with that idea. It's really exciting. It compels you to learn and stretch outside your comfort zone and acquire new skills and capabilities and relationships that you didn't even know that you needed. And then you get it over the hump and actually get it out into the world. And it turns out there are these crazy new applications for it that you also never envisioned. And so I can still remember what it felt like to pull the trigger on that powered ascender the very first time. We were over the swimming pool in MIT, just in case some issue happened. We had a second belay line on as well, like we always do, but it was over the pool because it was a nice big open space. And that feeling of anticipation before I pulled the trigger was one of the most intense, exciting moments ever. I've gotten to repeat that a couple of times since with some of these other experiences, but from that thrill of finding myself zooming on that rope, I still never would have envisioned that, you know, a line worker like this person would be using that technology to bond onto that's a live 145,000 volt transmission line. It is turned on. That person's body is at the same potential as that transmission line. And they're safe because they're wearing basically a Faraday cage suit. There's silver thread woven into the Kevlar suit that they're wearing. And of course, there's no path between the transmission conductor and the ground through their body. So it's just like a bird perching on a wire, right? There's no path to ground, so the bird's fine. But their body is at that same potential. That's totally true for that transmission worker. And we had to do a lot of additional R&D to make our system not get fried when it goes from ground potential where it was starting up to getting charged on there. And it's just amazing because, you know, some of the outcomes, in addition to being able to do these exciting rescues and climb buildings like you never could before, we've made it possible through adapting our technology to the transmission industry that that they can do jobs that they could never do before, or that would take tremendous resources to do. They have these amazing bucket trucks that can let them bond onto those live lines and do that maintenance. But those trucks are huge. And sometimes if it's a remote tower, they might have to build a road through the wilderness to get the truck out there to do that job. It can cost hundreds of thousands or even millions of dollars in some cases. But it turns out by adapting the gear that we built originally for rescue, making it work in this new context, even though our technology had been around for a few years at that point, it was new technology to the utility sector, and it makes a huge difference for them now. They can just take a little package with our equipment in it, overland on small ATVs, not build any roads, have no environmental footprint, launch the rope right over that transmission line, very special ropes, they're not conductive, and they can get the job done faster and safer and easier and more cheaply than they ever could before. Never would have done that. Who knows what else will actually happen moving ahead. It's so exciting to, even after more than a decade of working on power descending technologies, like I've gotten to through co-founding this company and helping grow it over the years, we're still running into new applications. And it feels so far from being a really mature technology. Like I heard a great example in a conference I was at yesterday, a really mature technology, right? A QWERTY keyboard we're all typing on. Not a huge amount of like brand new applications for it, right? It's really, we know how to use them. There's some great adaptations, but it's not going to open up any tremendously new, amazing capabilities. But other technologies like the power descenders that I've gotten to work on, we're still finding new cool things. And it's been such a trip to navigate all the unexpected challenges that lie between getting the prototype to work and getting it actually able to function in the world safely. I thought I'd share a little bit about what it's taken for us to do that and some of the skills that I've learned and continually rely on myself and with my colleagues and teams that I get to work with that help us make that final gap get bridged. Because I'll tell you, you can get a lot of thumbs up for your cool new technology, but without anybody actually buying it or being willing to try it out. And for good reason, right? Our company, Atlas Devices, we focus on high-risk occupations. We build technology that help professionals in those high-risk occupations work higher, faster, and safer. So we don't just do power descenders. We have really awesome ladders that fold up super tiny that can be rescue litters, and all sorts of additional cool technologies that we've gotten into as a result of the doors that have opened with the excitement of our power descender initially. But you know, if you're bringing in this cool new idea to the local utility, like say you've got this cool gadget, right? And even a great video of this neat Batman technology, and you walk into your local utility and you say, hey, guess what? Instead of using a bucket truck to access that transmission conductor, get this, you can launch a rope over it and haul yourself up. They're all gonna say, you wanna do what now? That does not sound safe. That's a horrible idea. Do you have any idea how many people are gonna say no to this? Even if they think it's a cool idea, that's the kind of additional challenge you run into. And so there's this whole extra subset of learnings that you've got to do, and communication skills to develop, and creativity to apply to innovating not only on the technology itself, but the processes that it's used by, and learning what's important to the end user to adapt that cool new capability into their scenario in a way that works for them and that's safe for them and that they're willing to adopt over their conventional methods. Because I can't even count the number of great jobs and thumbs ups that we got in between that initial development and getting people to actually use the gear in real world. This is a picture of me just having a good time. I feel so fortunate to be in a spot where I apply my creativity and enjoyment of building new things to my profession. And you don't have to have your own company to do that and to have that enjoyment. You can find that in any engineering career if you're creative enough and you have the same persistence that you're applying to your inventing in the first place. But I've really enjoyed and appreciated how the innovation process can facilitate that, I think, in a way that is uniquely open-ended and allows you to apply as much of your full self as you want to what you're doing, which I think is so important, and it's the kind of place to come from that facilitates the really wonderful game-changing innovations that are both exciting to work on and that the world needs the most. So our ass story, we started this project in college. We were students, a few of us working very mechanical, and we all were really good at making things and enjoyed having the resources to do so. Our professor was really great and allowed us to use his awesome machine tools after hours. So we would be grad students by daytime, and then at nighttime we'd be in there machining stuff, trying to build our prototype and make it work. So there's the CNC mill that we did almost all the initial prototyping on. There's me standing next to it with a couple of parts I had just made. The first prototype, all these green parts. And then in the bottom left, my partner Dan and I, Dan's our COO. He keeps all the activities running in Boston while I do a lot of the outside stuff, flying around, visiting customers and designing some of the new technologies. There we are. It's 4 o'clock in the morning in this picture. And we're just so pumped to finally have the assembly together that we didn't want to go to bed. We wanted to go try it out right away, or at least hang on it and see what that was like. So there we are, hanging on the door frame in the hallway in the middle of MIT. And fast forward a couple more years, we were able to take this forward through a lot of so many things that we didn't know. That's when you're starting off with something brand new, you don't know what you don't know. You don't even know what questions to ask. And all of you out there that have been working on exciting new inventions, I'm sure have a sense for that. And when I remember that I don't know what I don't know, when I'm starting off with something new, it makes it a lot easier for me to give myself the space to mess up and trip and fall on my face along the way, like one always does. And so I think everybody can get a sense for what my personal experience is of doing all these things. It's a lot of fun. It's not all fun. But for goodness sake, if it wasn't fun, I wouldn't want to be doing it. But this is, for me, this is what, I don't know, there's just, it's a unique feeling to get to bring something from your own head, put into the world, to try it out for the first time, and then get to see it through to where people get to have that new idea make a difference in their lives. It's fun, and it's also fulfilling and challenging in a way that I think for the kind of experience that I want in life, inventing and bringing those ideas into the world is just how I feel most alive. And so it's whenever I'm getting a bit bogged down in all of those ancillary details that wind up needing to be addressed to help facilitate all those exciting peak experiences, I try to bring myself back to what's fun about this. There can be a lot of that in any project. It's not all trying out the new idea for the first time. There's making sure that you're not blowing your budget. We've got to spend some time in Excel spreadsheets, making sure we can have the resources needed to get this thing all the way through. You've got to work with people and navigate the surprises and different opinions that come along with all of that. And you've got to take good care of yourself away. And sometimes if 8 hours and pushing really hard, it can feel hard to take good care of yourself as well. And so whenever a challenge arises that I'm feeling a little bit hung up on, I try to bring myself back to the fun that this is helping facilitate and the fun, larger experience that this is all a part of. And that helps keep me going as well. Teamwork is so key. You're all working in teams, and I'm sure will continue to do so for the rest of your lives. And this is so important. I could not do any of the things that I've been able to do without having been part of a team. There's even growing up, I was building a lot of stuff a little more on my own, but I was still part of a family team, and I had the mentorship of my parents and my granddad to help me navigate challenges and give me input when I needed it, and help keep me on track like any good team member can do. And the Atlas story is a team story. The other exciting projects I've done are also team stories like Design Squad Global on PBS, which maybe you've seen or had seen a long time ago. These are all team efforts. And well, I could give a whole hour talk about the importance of teams, but I'll just keep it to a couple of, I think, the most important things. When you have a team, especially one that's diverse and includes people from a number of different backgrounds and life experiences, the overall capability of the team is so deeply and importantly enhanced. I'm coming from a place of my own personal life experiences and stuff that I've built and problems that I've solved, and I get to bring that skill set and set of experiences to any situation. I'm really a fan of the saying, it goes well if you're ever working on inventing stuff, which is or trying anything new. So listen carefully. It goes like this: good judgment comes from experience, and experience comes from bad judgment. I fall back on that all the time. You just have to try new stuff and get those experiences under your belt to be able to have good judgment in any good situation, whether it's about managing a project or a specific technical thing where your technical expertise and good judgment has come from some experience. So imagine putting together a team with a really wide range of experiences that have allowed each of those people to develop their own special good judgment about a whole bunch of different wide topics. That is so much more powerful a combination than just a solitary person or a couple people who have almost identical backgrounds and life experiences. So that's one of the big foundations that helps make a team super powerful. Additionally, though, to make good use of all those experiences, you need to be able to work well together as a team. And especially if you have people whose good judgment is based on experience, they'll probably have some strong opinions about what's a good idea and what's not. And if those differ within a team, you can certainly run into some challenges. I know I've experienced plenty of that in my career and my life so far. And so being willing to work through those things and having a common commitment across the team to the core goal is so important to help facilitate everybody working together, even when there's a different idea from each person about what the right call is to make. And so that teamwork is a skill that the team needs to develop all together. Every team has its own vibe and its own groove and its own communication patterns. And just being aware of that and not trying to recreate a different team in a new one is important, because everyone has its own flavor. They're all made up of just different people. And then there's also the individual component of that commitment to the team and the way that you're willing to communicate within the team and help facilitate the teamwork yourself as well. That's also a critical part of making a good team work well together. And so it's a skill like any other that's just as important. In fact, in a lot of cases, even more important than any given hard skill that each of us might bring to a team. I wanted to talk about networking too, because my goodness, in the same way that the projects I've been involved in and excited about it's not been a solo effort, they've all been team efforts. How do you get a good team together? And how do you think about what a team means? What is the team? Is it just like the 4 people that started Atlas initially within that lab? Or can you also think about the team as that's the core team, but there's also a team of mentors supporting us. There's also a team of family members in the background helping keep everything moving if we've got to be totally dedicated to the project for a given time, or just providing all the personal support that's needed when stuff gets tough. Networking and the willingness to develop a network and getting familiar with the tools that are helpful to rely on when you're developing a network. It's so important. And I know, listen, I get just as nervous as anybody in a social situation where I'm showing up someplace new and I don't feel like I belong. I have that feeling all the time. And um, I trust so deeply in the value of networking, and I've had so many good experiences as a result of choosing to engage in networking that that I'm willing to get over the hump of my own personal discomfort to go and shake some hands and start meeting people. And one of the things that's helped make that a little bit easier for me is just putting it in a slightly different perspective, where I'm just trying to meet a couple people and maybe make a new friend or two. And I'll give you a trick that I like to use that's been really effective for me, both to kind of make it a little easier to meet somebody for the first time, and then importantly, also a lot easier to connect with them in a way that's memorable for both of you, in a way that can facilitate ongoing contact afterward, which is what you hope for if you're trying to meet some new people who might be able to help you with a thing or two in the future. So here's my little trick. Ask questions, and whenever possible, start those questions with either how or what. It's pretty simple, and it's simple enough that I can remember it and repeat it. And what that does is it naturally facilitates open-ended questions to let you learn more about them and learn what is exciting to them or cool about what they're up to. So an easy one if you're at a brand new event is, oh, what brings you here? And then they'll tell you a little something about themselves, what it is that brought them there. And that will give you something to build off of. Then ask another how, what question. Oh, what, how does that relate to the topics we're talking about at this seminar, or whatever it is? Ask a how, what question. And then with whatever they answer from, take the thing that you're most genuinely curious about and ask another how, what question about that. One thing will lead to another, and by the time you realize what's happening, you can be into a pretty interesting conversation where you are genuinely pumped about whatever that person is sharing with you. And guess what? That makes them also enjoy talking to you, because people enjoy sharing about themselves and talking about what they're pumped about once they feel comfortable in a given conversation. So you can use those tricks to your advantage, and just try to make it fun. You, just in the same way that you never quite know how an invention might get applied in the real world once it's out there. You never quite know who the people are, you never quite know what the expertise of a person in a given moment might be helpful to in the future for you. So for instance, like say, I don't typically try to network with a purpose. I just try to make a few new friends and find out what's interesting about them to me. Down the line later, those people tend to pop back into my head, and I think, oh, I am trying to figure out how to get our power descender through an airworthiness certification with the Air Force. And I remember meeting this person back at that event, and they were involved in an airworthiness effort for a related product. I think I'll give them a call. And that's how I wound up using those connections. You just try to learn about them, find out what's interesting to you about them. That'll make them memorable to you, and you'll have that recall down the line when they're willing to, or hopefully willing to help you out with some specific expertise. And another good, and so I'll just on that, like, follow up from networking, just to keep following this through a little bit more, to give you some tactical things you can use if you choose to. The way that I would probably engage with that person afterward is, hey, we met at XYZ conference and we talked about ABC, whatever you can remember, just to reconnect them with that memory of talking with you. You say, I remembered that you used to work on this FGH product thing, and I was wondering if you might give me a little input about this thing I'm working on. People often are really open to giving advice and input on new ideas, and it's a pretty easy ask. And so you'll often get somebody just, oh yeah, sure, what are you thinking? Keep it brief. You're just trying to engage a little bit and start rebuilding that connection into a more functional one where they can really help you out more deeply. But just asking for advice or a little bit of input on something is always an easy way to connect and follow up on one of those network things. So make a friend, get interested in what's cool to them, and then just catalog it, and they'll pop back into your head down the line when it can be helpful to you. I'm just gonna bring it back to this one again. Fun. Keep it fun. I find my brain seems to work really, really differently if I am slogging away on some task that is just sucking energy out of me versus working on something I'm excited about and feeling it like just wants to come into the world through me. It's I I have so much more trouble generating new ideas if it's a slog. If I'm working on something that I don't feel personally aligned with, it's a really shocking difference. And so if you're noticing that, I'd encourage you to just notice the kinds of activities that you feel like give you energy and that you could just work on all weekend, even if it weren't your job, you just want to do this. Notice what activities feel like that to you and what kinds of projects feel like that to you. And if you notice yourself feeling differently, just take note of that as well. If it's something you've got to be doing, then try to bring yourself back to what's fun about it. See if you can bring that perspective in a way that helps give you a bit more energy back. And if that doesn't feel accessible, then it's a good place to notice, like, maybe I want to try to get onto a different project or work on a different aspect of this or change a little bit of direction for what I'm getting exposure to. Because to me, having fun is one of the biggest indicators that we are bringing our very best out into the world. And even in the funnest jobs ever, like some of the jobs I've gotten to have, like, as I said, it's not all swinging from helicopters. There's a lot of the basic structure that has to happen too, and that doesn't always feel the same. But just as long as you can tie yourself back to what brought you there in the first place and what's energizing to you about that, that's what keeps you going when it gets challenging, because we all know that it will. And I think that's the way that all of us want to feel in our work and in our lives, is like, yeah, I feel good about this. I get to bring myself to this, and I get to bring what makes me me into this project in a way that helps other people. Man, if that's not living a dream, I don't know what is. And I feel so lucky that engineering and inventing can facilitate that so consistently. If we bring what it takes and keep at it, even when it gets challenging. So I'm going to wrap it my regular part of the presentation at that and say thank you all so much, and let's do some Q&A.
Let's do some Q&A. Nate, thank you so much. As Tony said over here in the chat, I often say inventing is just plain fun.
Yeah.
So thank you for the fun with a couple of exclamation points. And we know that our invent teams have had fun this year, and yet we know that during their year, there's been some hard fun in there as well. Mm-hmm. So anyway, hey, I'm always inspired by your Batman story. I often wonder what it would feel like on that helicopter.
It's kind of surreal. You're hanging in the middle of the air, which, if you've ever done any rock climbing stuff, like it can start to feel kind of normal hanging from a rope up high. But then I remember looking up and thinking, wait, what's holding that up there? Oh, it's not like I didn't know consciously, but the rest of my body was like, this does not make sense. It was pretty fun.
Hey, we got some questions over here for you. I'm going to start with fun first. What project was the most fun to do throughout your life? What was the most fun? And this is from Delilah in Wisconsin.
Thanks, Delilah, for the question. The most fun project. Well, it's a tricky thing to answer. I wouldn't feel like I could answer in a way that does justice to all the other projects. It's almost like asking which of my two kids I love those. there's every single project is special and fun in its own way. And some of them, I don't know if you know about the classes of fun. This is kind of a funny idea from outdoor activities like climbing and hiking and stuff. But there's class one fun, which is it's fun during and it's fun after. So like you're going on an easy hike, it's a nice time, and afterward you're glad you went on the hike and that was a good time. There's class two fun, which is not very fun during, but fun after. Like you did this really awesome hike and it was super challenging and you didn't feel very good for part of it. But afterward, you're like, oh, we made it to the top of that mountain. That was fun. Let's do it again sometime. And then there's class three fun. And that is not fun during and not fun after. Like, oh, there was a crisis averted. I did not enjoy that. Let's avoid that again at all costs. I've had all kinds of projects. And the one that is, I think class two fun tends to be the most fulfilling over the long term. Like class one fun, that's those are fun to throw in there. I do enjoy those kinds of projects and experiences too, but it feels better when there's some challenge and you had to go outside your comfort zone to some degree to get through it, because you can feel yourself growing as a result. You're growing as a person, you're becoming a more capable human. That's really fulfilling. Class one fun doesn't tend to bring that type of fulfillment along. So I will say that this Power to Sender project, it just keeps on opening new doors that I never would have envisioned. And I'm surprised and delighted at how consistently it does that. On the one hand, sometimes I feel like, man, like how long are we going to ride this thing? It's been 16 years since we initially invented it, and yet I'll be darned if we don't keep on finding amazing new applications for it that I never dreamed of, and for whom the new users are totally stoked because it's a complete game changer for them. And along with that, it tends, just because of the nature of that system where it lets you do things high up in the air, that tends to gravitate the project toward users who do some pretty crazy stuff, like bond onto live transmission lines or rescue people out of helicopters, and so that's definitely the project. It's the single longest project I've worked on. All the other ones were more like kind of a couple years max.
So Nate, how many people work at Atlas Devices now?
We have about 20 people.
About
so
20.
Yeah, it's a mix of technicians and engineers and a few former military people who have a huge amount of rescue experience, and so they do our sales, and then of course the people that help keep the company running in the background with all the books and things. So understanding accounting and important business things like that those have been really important at different career points too.
Yeah, very, very necessary people so you can have fun.
That's right. Yep.
Tony, do we have some more questions?
Oh, we have lots of great questions in from the Invent teams. What about, so a couple of people are wondering maybe about your mentors. Is there mentors that you've had or influences in your life who have helped you reach this point?
Yeah, so many. And when I think about the different mentors I've had, I haven't had so many mentors that I worked with like through my whole life. There have been a few, though, who have really made a difference for me. There's an amazing resource within MIT, and there's probably a number of them at more schools now too. It's called the Venture Mentoring Service, and it's a collection of former entrepreneurs affiliated with the MIT network, but not all of whom are necessarily alumni, but many are. And they've all had some kind of business experience and they want to give back and help. So they've created this wonderful service that's entirely free. And when you have a new venture, they will create a team around you based on what you're trying to do. They'll collect the right kinds of mentors with the right kinds of experiences and good judgment to bring to your situation. And it's almost like having a little board of directors, but they're just there to help. There's no conflict of interest. If somebody wants to invest, they have to depart the team. So you're never worried about if there's any ulterior motives. And those mentors were instrumental in helping us transition from just being students with a cool gadget project to a small company that can actually produce them and sell them to the government and make sure that we're doing that with good quality and in a way that supports the business for the longer term. And so we've had a collection of mentors with lots of different experiences. I still remember like the one that had lots of government experience, and wow, that was an eye opener. The government does business really differently from a lot of private companies and people. But the mentors that have been most helpful to me are the ones that are really coming from a different background from where I grew up. My parents are, of course, are the longest term and most meaningful mentors ever. And I spent my entire life, up until college, but now still, right? I spent my whole life picking up their tips and tricks for how to navigate the world and adapting those to my own situation. And so I really admire how both of my parents approach new opportunities. There's a great saying, I believe it's an Edison quote. It could be somebody else, so apologies if I misattribute it, but I love this quote, which is that a lot of people miss opportunity because it shows up wearing overalls and looks like work. And my parents both have a real knack for seeing opportunities to help and to do something cool, and being willing to figure out the work that's needed to bring that opportunity into fruition. And so that's something I've been practicing my entire life, at the expense of becoming overcommitted frequently and feeling overwhelmed a lot of the time. That's that's certainly a really wonderful formative core function to have. But the other mentors that have been really instrumental in my life have come from different backgrounds, and they help me get exposure to different ways to navigate the world and deal with challenges that arise than the ones that I grew up with. Because just in terms of my own personal development, I started to notice years ago that a lot of the main things holding back what I was trying to do had nothing to do with the specific technology I was working on. Like, that stuff worked just fine. The challenges in bringing it out into the world had a lot more to do with me and the kinds of ways I felt comfortable going after new sales, or trying to negotiate with a supplier to get them to deliver on time. It was something like, that's not something you really take classes for. And so the mentors that have been most helpful to me have had different upbringings. And as a result, their tool set for navigating the world is different. And they could come in, help identify my own blind spots, and then help me develop the skills and new tools to add to my own first tool set to help me navigate those situations in a way that was more effective for me in those new cases. So definitely people that have some different backgrounds bring the most to the table once you're growing up.
And that ties back into what you were sharing with us about teamwork as well.
Yeah.
Bringing different people to the table and having all of that input to build on.
That's
so,
right.
Hey, Nate, gosh, we could go on for another hour.
Yeah.
We have a lot of questions. Would it be okay if we sent you these questions?
Yes, please do.
So that you could answer them, and then Tony, if you could maybe put these on Canvas so our students can come back and revisit them, because there's some really great questions. We just kind of ran out of time.
Yeah, I'd be all over that. Maybe I'll even just record a video answering all the questions, and I'll send you a link for it.
Oh, that's awesome. That's awesome. Thank you so much. Congratulations for building Atlas devices into the company that it is. Thank you for helping those who have very difficult jobs in our world. You're welcome to stay with us. We're going to switch into our congratulatory mode for InvenTeams. if you'd like to hear what some of the Invent teams have been doing. Tony, I'll turn it over to you.
Awesome. Well, thank you again.
Take care, everybody. Congratulations to all.
Thanks. Thank you again to Nate for joining us
My
and
pleasure.
being
Take care, everybody.
part of this. So Sam, if you can go to the next slide, please. Awesome. So here we are again. This is our map. Just, you know, a theme we keep coming back to is that invention happens everywhere. This map certainly shows it. And I know this year, you know, in particular, our worlds may have felt a little small as we were working together to make things happen. But I really, you know, want to hit home that you all come from all over, from so many different backgrounds and life experiences. And I'm just so proud of what you were able to bring to your Invent teams this year. Lee and I were talking yesterday, and you all have really just wowed us with your persistence, your ability to work as a team, your technical creativity, your persistence in the face of so many challenges. So it's just really been a pleasure to be a part of your journeys. And we want to take a little time to celebrate you today. Sam, can you go to the next slide, please? So what I want to do next, I want to try this out. This is your program. This is your show. I would love to hear from each team just a little bit and hear maybe about a Eureka moment or a fun story from the Invent team year. We're going to go from West Coast to East Coast. So Archer School, we're going to call on you first. And I would love if somebody from your team could share one Eureka moment, one fun breakthrough or aha, or just a good laugh that you all had together. You can either raise your hand, use the raise hand if you want to volunteer and share for your team, or you can type something into the Q&A and then we will promote you to panelist, allow you to turn your microphone and share some of these moments together. So Archer, you are up first, and the rest of you be thinking about who might want to share and have something fun to share. So we'll give Archer, we're putting them on the spot, so we'll give them a minute, but I know a couple of you are with us here. And again, just raise your hand to be promoted. Or you can type it into the Q&A. Dublin, you're up next, so be on call. Awesome. So we've got it in the chat from Mike Carter. Mike, I'm going to, let's see here. Sam, can you move him over and maybe allow Mr. Carter to share for just a minute?
Sorry, I think a lot of our are having some issues connecting at the moment.
Oh, no worries. No worries.
Sorry, we were trying to do a shared connection and we had plumbing explode in our new building. So it rippled through as it had to shut down power and things in school.
Oh, no. So maybe you can share on behalf of the team then. It sounds like there was one big moment when everything kind of came together for you all.
Yeah, well, our project was a big integrated project. And so the students organized themselves into 6 different groups, some working on the app, some working on the device, some working on the motion programming for it and such. And a couple of big Eureka moments came when the teams had to come together to make their parts work together. And so when the app programming team was able to actually get their iPhone app to first talk to the code that the motion programming team was using to control the nozzle, was a huge aha moment, particularly when they were doing it over a remote sensing protocol called MQTT. It's this industrial protocol used for sensors out in the field. And particularly because a lot of these students had no experience programming coming in, but they were just so passionate about trying to make this happen and working with the InvenTeam's program that they went out and they learned. And we were using, I think, 4 different programming languages across 3 platforms, and they made it happen.
I love it. I love it.
And Mike, what was their reaction when that happened?
I don't know if the correct term would be squeals of delight or screams of delight, but giant smiles. You could hear it from the hallway where one team was working and from the other table where they were working. It's the joy is really infectious, although that might not be the right word in the time of COVID. But it spreads. It's just so wonderful seeing them work together and seeing how happy these, every little success, the happiness that it creates and the momentum that builds from it.
That's awesome. Thank you for sharing that.
I think we just learned that that's called class 2 fun. Am I using that right?
Class 2 fun, yeah.
That's awesome. That's awesome. So staying in California, I wonder if there's anybody from Quarry Lane who's got a Eureka moment. We'll give you a moment to see. Perfect. Let's, Sam, can you promote Rachel? I think Rachel's got a story or 2 to share.
I guess one of the biggest major point of our project was that we got the radio transmission to work. And at the very beginning, when we first started to use radio, it didn't work out as it's supposed to. And like we were literally screaming like right after we got it to work. And another major like an incredible joy that we were like enjoying was also about radio. We added the antenna and kind of reconfigured the entire electronic system a bit, but it didn't work out at the first time, obviously. And then after a few trials, it finally worked out, and I was so happy, and everyone else in the room was so happy as well. And I guess that's something that we wanted to share.
Thank you. Yeah, those moments when things just work, nothing beats that joy. So thank you for sharing that, Rachel. Next slide, please. Garland, Texas. Carmen's team down there in Texas. I wonder if you all have any stories. I'm just taking a look. I know not every team was able to join us today because there's school and other competing interests. I'm not seeing Ms. Diaz. That's okay. Okay. Well, I know they worked hard. And I got that joy email from them. That picture you see there, it was an odd time of day, but it works. It works. And it's just, when things finally come together, that seems to be a common experience for the Invent teams. What about Energy Institute? I see some of you on. I don't know if you have any stories that you all might want to share. I see Ben is here. Who else from Energy Institute is on today?
I can share something.
Awesome.
Yeah. So as you can kind of see from that infographic on the screen, one of the main parts of our design was a pellet extruder. And since we weren't actually able to meet in person for a good chunk of the year just because of coronavirus and stuff, it was really weird, like saying, oh, I have these parts, at school. I have this CAD, at my house. But when we were first able to, meet in person and start assembling that, that was probably the biggest Eureka moment for us because, we kind of started to see the fruits of our labor and see everything come together in a physical form. And also, even though this wasn't like part of our invention, finishing that final report at the very end, that was like a massive, I guess, relief and like a weight lifted off the shoulders, because we worked really hard on that. Yeah, so those were our two.
That's awesome. Yeah. Those final reports, I always tell teams, it should be a sense of accomplishment. I used to be a high school teacher, and there'd be times when I'd give assignments, and I always felt like if I didn't enjoy grading the assignment, it was my fault as the teacher. I gave a silly assignment, but I loved reading all of your reports, and that's just such a huge accomplishment. That's an artifact that you can take forward with you. That's a legacy, and it sets a bar at your school and your community. This is what we're capable of. So really nice job with that. That's awesome.
Yeah. Those final reports and the final presentations, those go into your portfolio. Those are very important for you as you go forward into college, or if you're not going to college next year, can be used for your college applications in future years.
Awesome. Next slide, please, Sam. Okay, Bram High School. They're one, I'm not sure if Bram was able to make it. I'm just looking at the list here. Well, I will share a moment with them that Bram is super excited that they're going to get a chance to. Okay, they're going to get a chance to share. Sam, if you can move that person over, I think we've got somebody from Bram who can share.
We have some state tournament games going on at the moment, so I don't know who else is all in. The big Eureka moment this year, we had called in one of our local community members who works at a machine shop just a couple hundred yards from the school, and we were asking them to supply a couple of the pistons, the actual pump variant pieces, and a couple of the students were drawing on the whiteboard what the overall project was going to look like, and he goes, you guys realize that's exactly what we make next door, and we can build all of that for you. And 2 weeks later it showed up, and that was when we started to go, we can make this smaller, a lot smaller than we could have made it if we would have done it here, and it would have taken us a lot longer. And that's when NASA really took hold and got super excited and sent us some extra inventory stuff. And there's been a ton of Eureka moments across the board here, just trying to figure out what pumps and pistons and cylinders and all those pieces that work. But when they figured out it could fit in that box, that was such a big moment in the whole process, and it changed the trajectory of what NASA was willing to work with us on, and all of the other fun pieces there. And I want to say thank you to everybody from MIT and InvenTeams and the Lemelson program, because this is just such an experience that we would have never gotten in any other way.
Luke, I really love your example because it kind of speaks to something that I think is special with inventing, is that you're actually working with your intended beneficiary. So like, to get that feedback from your partners at NASA, like, it turns it from what could have been a really fun and interesting school project into just the next level. And it sounds like it helped your team with that a little bit.
We never communicated with the owner of the company. It was always not necessarily parents, but friends, students, friends, parents that worked at the company that kind of set everything in motion. And I recently got to show the owner what we had done with the stuff that they had made. And I think there's a partnership for a whole lot longer in there, which is kind of nice. But you know, just the excitement that he showed when I rolled in there with the washing machine, it was pretty cool.
That's awesome. That's
That's
awesome.
pretty cool. Keep us informed as to how that partnership goes, okay?
Will do.
Thank you. So let's stay in Minnesota and Benilde St. Margaret's. I know a couple of you are on. See if you all have any stories. It looks like Sophia might have a story to share.
Hello.
Go for it.
Okay, so well, I'm on the Benilde St. Margaret's InvenTeam. I'm Sophia, and so with our invention, we made a mechanical arm for a wheelchair that presses an elevator button. And my brother is actually in a wheelchair. He has cerebral palsy, and so my aha moment was I came home one day and I was like, "Hey Xander, that's my brother. I'm working on this project for engineering," and he was like super excited, you know, because this could possibly help him later in life and give him a lot more independence. And just like knowing that my team has like the knowledge and resources to help someone like him or like just anyone else was very like exciting. So then it gave us the drive to continue working, and hopefully we'll continue working on this for a while and make it really good to help them. But yeah.
That's wonderful. Thank you for sharing that story, Sophia. You know, we always say inventors are empathetic. That's a core trait of what it means to an inventor. And you and your team were able to totally demonstrate that. So keep inventing, keep working on this project, and keep in touch with us. Let us know how it goes. Really, really great. And thanks for sharing. What about Amro? A couple of you from Amro are on. I can guess your story, but maybe you have a specific story that you want to tell. Sawyer's got a story.
All right, hi. Can you guys hear me?
Yes.
All right, perfect. So I'd say that our I guess Eureka moment was when we finally found, after I think it was 4.5 months, something like that, of trying to get a sensor that would actually sense the ice thickness. We finally found one that could do that. And so that was pretty exciting. I think it was like 6 o'clock at night. We were still at school working on the project. And just finally found something that worked. And it was interesting though, because we had already tried basically the same project. But then we had some expert help, and we tried it again, but slightly differently, and it worked. And that was really, really exciting. And like, finally, we have something that actually works. Like, our idea can be possible, and we can actually do this. So that was really cool.
Hey, Sawyer, where did that expert help come from?
That was Paul Fusil.
Yeah. I'm so glad you got to work with Paul. He's what we call our Uber mentor. I think he has certainly enjoyed working with your team, and Mike Carter also says that Paul is an amazing mentor. You know, Paul doesn't have a whole lot of time to mentor invent teams, but he does reach out to us every fall to say, okay, who can I best help with my skill set? So I'm certainly glad that Mr. Fusil was able to take time out from his many calls also with NASA, wasn't it, Tony?
That's right.
To help the Omro High School Invent team.
Yeah,
That's
he
awesome.
was super helpful.
Yeah, I chose this picture for your slide. I know that you all have a beauty shot of the invention, but this was the picture that I got from Paul that moment that it finally, the proof of concept was there, which is really cool. Thanks for sharing, Sawyer. Next up, Sam, where are we traveling next? Over to Michigan, H.H. Dow Invent Team. Who do we have? Laura. Laura has a good story for us. Oh, lost Laura. Anybody else from Dow can jump in? Abigail can jump in. Thank you. That's teamwork. And Laura's back too.
Sorry.
We've got, awesome. We've got Laura, and then we can bring Abigail over too. Maybe you both have the same story or something different.
Yeah, I can share part of it, and then Abigail can probably share her own ideas too. Sorry, it took a while to rejoin. So I think one of the biggest Eureka moments was actually not so much technical. It was when we got to present about invention and invention opportunities to a class of fourth graders. They were so excited. There were so many questions. And so it's just seeing that engagement with just the younger kids and like how excited they really are to have these opportunities and to seek out these opportunities for themselves. That was I guess, a Eureka moment for me, which wasn't so technical, you know?
That's wonderful. Yeah. Abigail, what about you?
Yeah, so I totally agree with Laura too, but I guess on the more technical side, I think one of the big Eureka moments for our team was when we communicated with like local officials and wastewater management employees, and also we communicated with a few people from the CDC and also the EPA, and just realizing that they were excited about our project and really saw potential and usefulness for what we were inventing. I think that really like confirmed that we were doing meaningful work. And yeah, so that felt really good when we were able to communicate with them.
Was it kind of scary reaching out to like CDC or?
Yeah, I'm sure Laura can talk a bit more about that, but I think it was definitely a big step for us to take, but you know, what's the worst that can happen? So we just, you know, decided to talk to them, and I don't think we were expecting like much feedback, but they definitely exceeded our expectations. So
I think it was for me, at least, when I like reached out to them and just kind of, you know, looked into who would be the person to contact at the CDC about this and our invention and who would be interested at all or be able to give us advice. So I was really going into it not expecting a lot at all. You know, I thought I'd send it, you know, maybe get a response, like a general response. But in fact, who we talked with, Miss Lenhart, and just also, I guess, CDC as a whole, was super responsive, scheduled a Zoom meeting for us. We were able to discuss our ideas with her. She gave us some very valuable information. And so it was just overall, I think it was more exciting than scary. And yeah.
That's great. Now, wasn't it your team that reached out to a professor at MIT as well?
Yes, it was.
Yeah, who reached out to who?
So that was Caleb, and it was when we were kind of looking into the sulfonated polyethylene, and so this professor had done some research on it, and I think Caleb was the one who reached out there, and we got redirected to one of his PhD students who was also very helpful. Yeah.
Yes, so we're glad that Professor Langer's lab was helpful. So Congratulations on reaching out and sharing what you were doing and getting feedback. Awesome.
Thank you.
Hey, where next, Sam? Atlanta, Drew Charter School. What about you all? Do you have a Eureka moment, an aha moment? Good. Alexandria Sweeney.
So our biggest Eureka moment would be probably the first and only time the hardware team was able to work in person, because we were able to integrate a lot of our devices together, which we were really struggling to do virtually.
That you just can't replace those moments of sitting side by side and doing some of that systems integration. It sounds like that was very similar to what both the Quarry Lane School and the Archer School for Girls talked about. Like, our pieces work together. Like that's such an exciting moment, and that's such a complex technical thing to do. So congratulations on that milestone. I see Maya's got her hand up. Maya, is there something else you wanted to share too?
Yes, I do actually. It was when we kind of met with the ethics coordinator of our school, and we saw like the real impact of our device. So ours is tackling police brutality, and this coordinator for our school has actually had a family member who was targeted by police and actually lost their life. And seeing her, I guess, break down and actually realize how much this could have helped her family member actually kind of made it real for us. So that was also pretty impactful.
Thank you, Maya, for sharing that. I think about what the quote that I shared from Emily on the Ridgewood team yesterday is, I hope through this experience you all realize that your work is meaningful and your work is impactful. And being able to make those connections like Maya, you described, or like the Benilde St. Margaret's team described, when your invention is personal and you know the kind of impact it has, know that you really are making a difference in the lives of others. And that's the power of invention. So thank you again for sharing, and for really great job with all your work this year, Drew. Great. Tampa, Florida. Who do we have? Let's see, Anish has got something great.
Can you hear me?
Yes.
Okay, yeah. So we had several Eureka moments throughout this process in sequential order. First and foremost, receiving the grant in September was probably the biggest Eureka moment, because it sort of was a confirmation that we were going to be able to pursue this project, because without this, we would not have had the funding to purchase the parts and get the mentorship that we did. And then after that, finalizing our CAD model was a really big Eureka moment, because we went through several, like 4 different iterations of CAD models before, and finally we landed on one that was able to meet all of our criteria and constraints. And then getting the monitor to turn on the front of our device was really cool. That was something we were working towards for a very long time. EurekaFest 2 days ago, our presentation. And finally, 2 days ago, a local news network in our area in Tampa reached out to us and 2 of our members, including myself and Tanu, she's also on this call. We had the opportunity to interview for this news network. And today, this morning, an article got published about our work and the InvenTeam's program. So,
oh, yeah. That's awesome. That's awesome. So it was a year full of Eureka Moments for you all. That's great. And I love, mentioning, just the media outreach connections. I know a number of invent teams have had the opportunity this year to talk to the local media and just to spread, what you're doing and get the word out there, and let your communities know, hey, we're inventors. We're making a difference. So that's great. Congratulations and thank you for sharing. Okay, coming up the East Coast, Ridgewood High School in New Jersey. Who's got a Eureka moment they might share? Elliot. Jump on in, Elliot. Well, Elliot is coming online. The team in Midlands might like to know. This is a picture of the Ridgewood Invent team presenting to the middle school. So a couple of teams were able to do some of that outreach to younger kids this year, which is above and beyond the call of duty, but I think so special and so important. And I'm glad that you took the time to do that.
So one Eureka moment for us was how we kind of evolved to include a stir in our invention, because originally we were kind of so confident in our technology that we didn't think we would need to have anything else. We thought we could just have a cap with a battery and an electrode in it. But then when we were testing in someone's house, we were seeing that basically no hydrogen peroxide was coming out, and we had to try a bunch of different ways, like pumping water through it, moving the electrode, and then eventually just putting a stir in it, which kind of increased our understanding of how complex the technology would have to be.
That's awesome. Thank you. Yeah, I know, allowing yourselves that space to change up, try new things, collect data, test, retest, redesign, retest, allowing yourself just to go through that invention process. And then you got to see the rewards of it, which is really special. So really nice job. Thanks for sharing. Next, Smithtown. Eric, take it away, Eric.
You can go. Yeah. Okay. So sorry about that. So I would say our Eureka moment was, so in the beginning of the school year, obviously like COVID was happening, and it's still happening right now, but it was much worse. And we were hybrid, so half the school would come in for 2 days of the week and half the school would come in the next 2 days. And so this made it really hard for us to like communicate, as we're not really together full time in school all together. So what happened was, in about January, we tested a device for the first time, and everybody came in together and got to see the device, which was probably a really cool moment for us, because it was the first time like all year we got to see each other all in one location. And we also got to see the device work for the first time on a breadboard, which was really cool to witness for like many different reasons.
That's awesome. As Lee often shares with us, invention is a team sport. And when you can celebrate those milestones together as a team, nothing beats that. And I think that's a little bit of what Nate Ball was talking about too. So awesome, team. Thank you for sharing. And then Landmark School, Caitlin, awesome.
Hi, can you see me?
Yes.
I think one of our really big Eureka moments was when we got our first model of our buoy all like made, and we put it in the water, even though it did get hit by a boat. And we did lose a lot of our technology. It was still like a very big accomplishment when we put it in the water. It's like, wow, we really made that. And I know that when we get our second buoy that we're making right now, all the technology sorted out and then we put it in the water, it starts to collect data that we can give to like different corporations around our community to help with like climate change and understanding the ocean climate around us and how like we affect the ocean and how we can better our ocean life. It'll be like really big because we'll be like trying to help people around us. And I know all of my team is very excited about that.
Thank you, Caitlin. We're all really excited about that too. So once you get that next buoy up and you start getting some data coming in, please share it with us.
Yes,
love
definitely.
to be able to see it. Great
Thank you.
job. That's great. Well, I really appreciate you all sharing. I just wanted to give a quick shout out to our seniors here. Here's just a small sampling of where some of our seniors are off to next year. Continue to do amazing things, continue to invent. In the most difficult of year, you all have proved what's possible. So imagine what you'll be able to do in the future when you're not bound by physical distancing and things like that. So congratulations, seniors. Best of luck on your next steps. And please keep in touch. And of course, all of you who haven't graduated high school yet, please keep in touch with us too. And I know many of you have plans to continue moving these invention projects forward. And we always love to hear what you're up to, how your projects progress, or even new invention projects that you take up
I guess,
to.
Tony, one thing that I'm thinking about is if these students were able to invent this year, they can invent in a year. So congratulations to our seniors. Great seeing this list, and kind of wondering who's going to be at Northeastern, not far from us. And but wish all of you the best of luck in college, as well as in your studies, for those of you that are continuing in high school. Tony, I think
Awesome.
we have time for our InvenTeam awards, and then we can break at about the time we had expected to for Professor Michael Sema to share
Exactly.
with us.
Yeah. So each year we love to recognize different teams for different great things that they've done. Of course, the technical aspect, but we'll start here with communications. The Archer School, you have used social media so well to share your story and give that behind the scenes update. Your blog posts have been great. And I encourage everybody, if you haven't seen it, to go to the Archer InvenTeam's page. And you can see that they even got a shout out from Oprah. And I don't know that an InvenTeam has had a shout out from Oprah before, which is pretty cool. So way to go, great job. When you can share out your invention story, it just gets more people excited, more of those connections, and it just reinforces that what you're doing is so meaningful and impactful in your community. So great work, team. I wanted to split the research award two ways for two different reasons. I love that the Ridgewood InvenTeam went out and worked with Ridgewood Water to get real certified results back to validate the claims of their invention. So now they have hard data to say exactly which bacteria after 30 minutes their invention removes and kills off in their water. So being able not just to create the device, but to collect the data to back up your claims, that's really special. Smithtown High School West, what you all have done is a first for an InvenTeam, which is to get not just IRB approval for a survey, but a full approval. And I know you haven't had chance to collect that data yet, but this is a huge accomplishment for like professional scientists, not just an InvenTeam. So you all are trailblazing there. And I really look forward to seeing the results of that research protocol that you've designed. And I think it's really going to help you and your team make an impact through this invention. So congratulations to you both. Really, really nice job in seeing how research and invention go hand in hand. The Sustainability Award is the Gilbert Reed team in Texas. They had multiple students go through and receive the SolidWorks Sustainable Design Associate Award, so they can really think through what is our responsibility as inventors. I know a lot of teams had sustainability focused inventions, but as inventors, every decision that you make, you can have and make it through a sustainability lens. And the GRCTC team did that really well this year. So congratulations to them. The financial award, all of our plans were well made and we had to throw them out the window this year. But the Landmark School did such a good job of consistently spending throughout the year, having plans and spending and testing. They did a great job of working with Alma to get their receipts uploaded in a timely fashion. Being able to do that administrative part of the InvenTeam is so critical and allows your projects to move forward. So really nice job, Landmark, of using those funds and using them wisely throughout the year to support your inventing process. And then we have one special award. Our friends at MIT Beaverworks, which is part of Lincoln Labs, they like to look at the invention projects and award what they call the Golden Beaver Award. You can see a picture of it there. It's 3D printed and it's on this beautiful wood base. And they give out an award each year to an invent team based off its technical merits. And this year that award went to the Drew Charter School Invent Team. They loved the complexity of the system that you talked about, where there were 5 or 6 different sub-teams that had to all get everything talking to each other. They integrated some serious computational tools, including machine learning technology. And this was just a really technologically advanced device. So way to go to the Drew Invent team. And we will mail this award to Miss White, and she'll get that later this summer. So great work, you all.
So I often say that we are cheering you on from Cambridge. And I wanted to give a shout out to who we actually are. This is the team at the Lemelson-MIT program who cheers you on. From those very small accomplishments to the super large accomplishments like EurekaFest this week. So Michael, Stephanie, Betsy, Carolyn, Janelle, Laura, Alma, Sam, and Wendy, we have cheered you on for this entire year. So I want to recognize the Lemelson-MIT team and personally say thank you to our team members here in Cambridge for your ongoing support of the Invent teams. Next slide. We also would like to recognize the extension of the Lemelson-MIT team, and these are our master teachers and mentors. Don in Oregon, Mike in New York, Shelley, Arizona, Doug, Massachusetts, Mark out in Minnesota, and Ed out in California. And a special shout out to Paul Fusil, who has worked with so many of our Invent teams over the years. Not a master teacher, but certainly a master mentor. So these are all folks that have been with you throughout the year. And quite honestly, I believe that they will be with you if you want to reach out to them in the future for any advice or inventions that you're thinking of working on. So thanks to my team for all of that great work throughout the year. Tony, I think we're right at 1:30, and perhaps this is when we should invite Professor Seema to join us. Sam, do you want to maybe
Sam could stop the slides for a minute?
Yeah. And maybe move forward to slide 30. Michael, are you with us?
I'm here. How are you?
Great.
I've been listening for a while. And I think we owe both you and Tony a real thank you for yet another year of a great group of invent teams, and it's been a really real pleasure again to meet all these students. At least, well, not exactly meet them, but at least hear their pitches and get a little bit of exposure to their teachers. And so I think we owe you and Tony a great deal of thanks. So
It's always our pleasure.
look, I just want to thank all the students and the teachers for their dedication this year. I know it was a real challenge to work on these projects. I hope you learned, though, just how important it is to spend time designing things. And we call it invention, but in a broader context, it's really design. And understanding a problem, hypothesizing a solution, and building a prototype and testing it out. So many of the students at least, will be going on to colleges. I saw the list there, quite impressive list. I've worked at a university for a very long time, 36 years. And of course, I was in school before that, so I've got a lot of practice at it. But one of the things I learned is that the same goals of being an inventor, the same skills to be a good inventor, turn out to be the kind of skills you really want from your education. And there are 3 key skills to be a great inventor or innovator. And the first is curiosity. I claim that's a skill. And the reason is curious people are always collecting solutions to problems they haven't encountered yet. And all the things that you run into that surprise you, maybe someday you can use in solving a design problem. The second thing, and you learned this in your projects, but this is something you should focus on in college too, is that good engineers, good designers, good inventors know how to get into the shoes of the user and see the world from their perspective. And that's how you make the best products. You're not making the product for yourself, you're making it for somebody else. So you have to have empathy. So practicing empathy, developing the skill of empathy is really important to be an inventor. And I think it's one of the goals of college education too. And then finally, I think you touched on this in your InvenTeams project, is that no one of us has all the skills necessary to solve a given problem. But the best inventors, the best entrepreneurs can recruit people to help them. And what I call that is leadership. So that's another skill that you have to develop. And I say recruit because great leaders don't tell people what to do, they lead them. And so those 3 skills, curiosity, empathy, and leadership, not only are important for inventors, but they're what you should do when you go to college. And then, finally, it was interesting hearing about people's Eureka moments. And, I've got a lot of patents. And having worked as an engineer and designer for a long time, I've had a lot of Eureka moments. And I was thinking to myself, what is the most important Eureka moment that I came across? And I can't say that there's anything important, the most important. They're all meaningful. And but probably amongst my first patents, and may have been my first patent, came out of the late 1980s. It was with a colleague of mine here at MIT. We were both junior faculty members. And the late 1980s there was only a few people in the country and indeed in the world working on the idea at that time we called solid freeform fabrication. And you know it as 3D printing. And in fact, what came out of that period was about 4 groups across the United States were working on 4 different technologies. MIT's was one of them. And now, and there were a number of Eureka moments that we all had. You know, this was stereolithography, MIT's technology, selective laser sintering, fusion deposition modeling. All of those things that you've run into all started at that time. I knew all the inventors. It was a very small world. And we all had these Eureka moments. And at that time, all of us were struggling to make things that worked, and most of the time they didn't. And but we learned so much. And every time there was a mistake, it was like it was a Eureka moment, because it told us what we had to do next. And now look at it. You know, just one of our licensees, our last remaining licensees, because the string of patents is almost all in the public domain, is Desktop Metal. And they're worth today something like $3.1 billion. Just one company. And think of all the people employed and all the kids that are being, their tuition is being paid for by people being employed in this technology. It's amazing to me. I look back on it, and just the very first thing that I got a patent on ended up being changing the world. So, at any rate, I want to thank you all. Take it over, Lee.
Michael, thank you. And I hope you noticed how your patent so many years ago has led to the education of the students here on these invent teams.
It was amazing how many high schools I would go to over the years, that they would give me a tour of their shop or something like that, and there would be a 3D printer. Yeah. In fact, one of the licensees, and they had no idea that it had anything to do with the developing of those technologies.
Well, certainly, Tony, I think what 2/3 of our invent teams had a 3D printed part this year.
Right.
At least 2/3.
Yeah.
So
now,
anyway.
arguably, it's not. There were at least 4 different flavors of the technology, but I knew all those people. I mean, it was a very small group of people working on these problems.
And now they're who knows how many. Thank you, Michael, for sharing part of your afternoon with us.
Thank you.
Thank you.
Take care. Sam, why don't we go back and pick up with our, let's see, we have some awards now for the design challenge, Tony.
That's right. That's right. It was so much fun to watch your videos and all of your submissions for the design challenge. Thank you, everybody, for working hard on that and getting those submissions in. We have selected a few, and we'll share those with you in a minute. Reminder for those of you who are selected, I'll reach out to you afterwards and we'll we'll allow you to pick what you want from the coop. And you and your team, and we'll just ship you your award.
Tony,
directly.
what's the coop?
The coop is the MIT bookstore, where you can find lots of really fun, really neat MIT stuff that you really can't find anywhere else. So just yet another reminder that you all are inventors and do a great job. So Sam is going to bring up the videos. Let me just pull up one thing on my screen so that I'm ready to go. Sam, let's start with, I think it is team, what is it? Group 1. Let's start with group 1. Awesome. And can you play their video?
Hi, I'm Delilah Larson. I'm part of Group 1, and our group decided to go with the automated plant water. And for our design, we kind of had this, the picture would be a sad face as soon as the sensor is put into in like dry soil, like so. And then essentially we wanted the motor to kind of like trickle water above it, and then the picture would change to a smiley face once it was put into the moist soil, like I have here. But there was a lot of troubleshooting and errors, so that with the motor, so it didn't become a final product like we wanted it to.
I love what this team did. One, because they took on a huge technical challenge to learn a new technology and get that reduced to practice as far as you did in 36 hours is pretty darn impressive. So way to go, team. I will reach out to you in a little bit. Next will be Rachel and Harini's team. You can share their video, Sam.
In this day and age of screens and lockdowns, where nearly everyone spends the majority of their day at home sitting on a chair, it's more important than ever to remind oneself to get up and move around on occasion. We fall victim ourselves to sitting for excessive hours and forgetting to stand up and stretch. That's why we chose to tackle the prompt, get up and move.
Our device is a sit cushion that the user will sit on. A button placed inside the sitting pad is pressed when the user first sits on it, which triggers a 58 minutes countdown. If 58 minutes are up, the user is still sitting, the sitting pad makes a loud beep until the person gets up. When they get up, 2 motors with cardboard attached spin for 2 minutes, making it impossible for the user to sit back down. It forces them to spend that time standing and stretching. The current prototype looks a bit bulky, but a future iteration will see the electronics made more compact through soldering, or also proper cushioning will be included for comfort.
Our invention is unique because currently, other devices on the market are quite expensive, such as the Dharma cushion or the Rise. They have unnecessary features such as recording and tracking the user's heart rate, respiration, and movement. They collect and share your health data to apps and to other people. Our simple sitting pad performs the most important function, so it's efficient and focused. It simply tracks how long you've been sitting and signals you through a sound and forces you to stay up for a bit through the motors. It is affordable as it uses simple materials, and it is also comfortable and portable, because you can take it with you and use it on a variety of seats.
Awesome. So this group, you were actually selected by this year's Lemelson-MIT Student Prize winners. They're in their own training right now, but they watched all the submissions, and this is the one to them that they were most excited about. They loved the creativity, they loved the video and demonstration, and just the complexity of it all. Both of these students were on the Quarry Lane School InvenTeam. And what I noticed, and I don't know if you all were influenced by your own invention project, because your invention project, you figured out how to make vibrations from motors during the InvenTeam year, and you applied that same idea to a new problem, which is really cool. So great job, team. Let's do group 41 next.
From group number 41, and Elliot and I decided to do the Get Up and Move challenge. And so we created a prototype which looks like this. And it's unique, obviously, because of the case, which I made myself, and also the code, which Elliot designed in a large part. So basically, how it works is when you turn it on, which you do using the little cutout in the back, you turn it on, and it reads out, "Hello," to greet you. After that, if it doesn't detect movement, it starts showing the little man doing jumping jacks, and this is supposed to indicate that you should get up and move. And so when you do this, you get up, you shake it, there's a little check mark which shows up. And this check mark sticks around for about 10 minutes, after which the jumping jack man will show up again. The movement from the jumping jack little person will indicate that you should get up and move. Elliot also designed a code in which there's an auditory cue for when you should get up and start moving, or when you've been sitting too long, which is also helpful, obviously, for the challenge. Thank you.
Awesome. Of course, the teamwork and collaboration was apparent in this one, how you both brought different things to the table, and also showing that you don't need a lot of fancy stuff to invent. I loved the case that you made. That was really neat. That's something that people would want to have with them. Awesome. Group 5 next, please.
After experimenting with the first 2 prompts, the first one being the automated planter watering and the second one being the get up and move prompt, I ended up settling on the second one. I believe combining the built-in LED array on the microbit with breadboard circuitry to simulate a buzzer system makes my invention unique. My invention works on a timer system. The LED array on the microbit counts down to 10, and when it hits 0, a heart appears on the array and the buzzer buzzes, indicating that the user must get up and move. As soon as the buzzer buzzes, the LED array displays a figure doing jumping jacks to give company to the user. So I'm going to plug my invention in. And here it is. So right now it's counting down from 10 on the top, as you can see. And when it hits 0, the heart displays and the buzzer buzzes. And now it's doing the jumping jacks. The LED array is right here. The buzzer is right here. And I used the SparkFun component that was provided, which allowed me to connect the microbit to the actual breadboard, and allowed me to use jumper cables to actually power the buzzer. So yeah, thank you.
Awesome. Right at the beginning of the video, you mentioned all the different things that you tried and all the other things that you explored. And that's really important as an inventor to do. So really, really nice job. And one more team we want to highlight, and that's team 6.
Prompt that we chose was get up and move, and we are design team 6. Our invention is called the Cardboard Motivator 1000. This invention aims to encourage people to get up out of their seat and get in some movement as they're working on their device. And it powers on once a button is pressed, and every 30 minutes, the cardboard motivator will flip onto the computer and block the screen. Then a 3-minute timer will start and end with it freeing the computer screen. Then the process will repeat until the button is pressed again. And for this prototype, the timer is 10 seconds long to model the real process in a shorter amount of time. And our invention is unique because unlike popular apps for screen time management, our device uses a physical device to block the screen. In addition, healthcare professionals and researchers say it's important to get up and move every 30 minutes. So our device also follows this regulation. So these are the components that the Cardboard Motivator 1000 uses. And these are a couple of pictures of our fabrication process. And here is our program that we used. And here's a short demo on how the Cardboard 1000 works. Thank you for taking the time to watch our invention statement.
I'm sure that many of us, myself included, would have benefited. Yeah.
I need the seed. I need the cardboard that comes across the screen. Yeah. Oh, how fun was that?
Yeah, the apps you can always just ignore, but you can't ignore the cardboard in front of your screen. So thank you again for all of your hard work. I hope the design challenge was fun. I hope you got to meet some new people and try something new and different, and you've got your inventor's kit you can take forward with you. And I hope you find more things to invent with it. So that is it for me, and Lee, I will hand it back to you.
Well, Tony, it is now time for the Tony Award. Tony, this was a very difficult year, and yet I know that our teams have done as much great work as they have done because of your guidance. And from me, from the Lemelson-MIT program, the 2021 Tony Award goes to Tony Perry. And because we love the Golden Beaver so much, there is a Golden Beaver coming your way, and it's the 2021 Busy Beaver Award. It's made especially for you, Tony. We cannot thank you enough for everything that you've done for our Invent teams this year, from reorganizing, the word pivot comes into our lexicon now. We pivoted constantly this year, and all the way through EurekaFest, right up to the wonderful design challenge that you and Shally and Sam Situ put together. Just an awesome 2020, 2021 Invent Team year. So thank you very much, Tony. And in closing, I would just like to say thank you to all of our teachers once again. Our students are with us, our Invent Team students are with us because of you. We could not do the work that we do with young inventors without our teachers. This is an image when young inventors, when you think, where in the world will invention take me? This is an image taken from the White House lawn. So inventions can take you to places you'd never, ever imagine. Nate Ball says that, he could never have imagined, looking up at a helicopter. Professor Seema never imagined where that first patent of his would lead. Take what you learn from this Invent Team year, take your empathy forward, take your leadership forward, never lose your curiosity, and work to find solutions to improve the lives of others. So proud of all of you, and we will continue to cheer you on from Cambridge. Tony, any closing words from you?
Well, I would just echo everything you just said, Lee. I've said it 20 times and I'll say it again. Just how proud we are of all of you as Invent Team students and teachers. We look to you to tackle these big issues. Inventing is important. We've heard that as a theme the past 3 days over and over. There's a lot of work to do in our world, but I'm optimistic because I know each and every one of you, and you see what needs to change, and you have the skills and the ability, and I hope through this process you see that yes, you can make a difference. Inventing is one way to do that. So please enjoy your summer, get some rest, recharge, relax, and keep in touch and continue inventing, and know that Lemelson-MIT program is always here for you. Thanks, everybody.
We're always here. Bye, everyone.